guys. So we're going to start working with today is we're going to start working with analyzing similar triangles. We're going to start analyzing similarity, right? And so we've already worked with this without you knowing about it, but we're going to go fully into it now for the next couple of lessons. So what we've always worked with is triangles being congruent, right? If two triangles were congruent, we knew that they were always exactly the same, right? Similarity is something that's a little bit different, and some of you may already know it just based on the word similar, right? Let's say we have two triangles, like this. Automatically, we know that these two triangles are not congruent, right? The way that we know that these triangles aren't congruent is because one's bigger than the other. Congruent means that it's exactly the same. So if something's congruent, they have to be exactly the same everything, same shape, same size. Similarity is when you're dealing with this. Now, similarity is a situation where you have the same shape, but they're different sizes, right? And what we use is a word that we use to refer to it, and it's called alike. When you're dealing with similar figures, when you're dealing with similarity, you're dealing with shapes, figures, polygons being alike, right? And what I mean by alike is, again, same shape, different sizes. And that's what we're going to be analyzing today. We're going to be analyzing how the sizes come into part to be able to analyze whether there is a relationship between the sizes, right? So looking at this, we have two triangles. The way that we actually analyze whether these figures are similar is by looking at something that's called a scale factor, right? A scale factor. Let me bring out the word for you guys. Sorry about this. It's something that's called a scale factor. And what a scale factor does is a scale factor is a number that actually tells us how the figures are actually changing, whether they're actually changing equally or whether they're changing differently, right? So whenever we're dealing with figures, and let me start throwing in numbers. Let's say that this side here is going to end up being 9 inches, right? That's 9 inches. Let's make this one. Let's make this one. Let's make this side here 12 inches. Let's make this side here 6 inches, right? And that's 9, that's 12, that's 6, right? Let's say that this side here is going to end up being 3 inches. Let's say that this side here is going to end up being 2 inches. And let's say that this side here is going to end up being 4 inches, right? So now we have measurements. We actually want to start looking at whether these triangles have similarity between them, whether they're alike. And the way that we figure out whether they're alike is by calculating the scale factor. The way that you calculate a scale factor is you join the sides that correspond to one another and you divide them, because you're trying to see whether it's gotten bigger, whether it's gotten smaller, whether that change in them is the same, right? And so a bunch of you are looking at this, and without even thinking anything else, you guys are already starting to realize that there is a relationship. And it's that relationship that we're talking about whenever we're trying to figure out if shapes are similar, right? It's that scale factor. So if I start looking at this, right? We see 9 and 3. We see 4 and 12. We see 6 and 2, right? The way that you calculate the scale factor to see if it's actually similar or not is by dividing them and joining them. So the one thing you always have to be careful, and don't always go by left side with left side, right side with right side, it's the sizes that matter. So for example, we have this triangle here. We know that our biggest side is 12, right? Our biggest side is 12. Over here in this triangle, our biggest side is 4. So we take those two and divide them, right? And it's always division. The way you always find a scale factor is you divide. So 12 divided by 4 gives us 3, right? And again, always remember, biggest side with the biggest side, then we put smallest side, the 6 divided by the 2, because we always put the smallest side with the smallest side. 6 divided by 2 gives us 3, right? And then we put the middle sides, right? The 9 and the 3. 9 divided by 3 equals 3. And so if we're looking at this, automatically you already see something. That this scale factor was 3, that's a 3, this is a 3. Sorry about the marker, guys, dying now. We know that those two are 3s. And so looking at those two, the fact that they're all the same exact scale factor automatically tells us that these figures here would be similar. And that's how you actually calculate whether figures are similar or not. It's by calculating the scale factors. If the scale factors are all the same, they're similar, right? If any of these scale factors are different, even by a little bit, if any of them are different by a little bit, automatically it's not similar. Because for it to be similar, all of them have to be exactly the same measurement. Always, right? And we have words for that. We're going to get into that. So always remember, what is scale factor? Scale factors must all be the same. Always. All scale factors must always be the same. And it's not by a little bit, it's not close and all that. All of them have to be exact. Always remember that. And there's a different way to see it, because sometimes people think that you have to start in a certain order. You don't, guys. Over here, I started with the biggest triangle first. You can do the opposite. If you want to start with the smallest triangle, you can. Because if I want to start with this, again, let's start with biggest side here is 4, right? So we're going to do biggest side of this triangle is 4. Biggest side of this triangle is 12. 4 divided by 12 gives us 0.33, right? And now always remember, if you start with the small triangle, keep starting with the small triangle. If you start with the big triangle, keep starting with the big triangle. The next side would be, again, the middle side is 3. The middle side here is 9. 3 divided by 9 is 0.33, right? Smallest side here is 2. Smallest side here is 6. 2 divided by 6 is 0.33. So that's what I'm trying to get you to understand. It doesn't matter, guys, whether you start with the big triangle or whether you start with the small one, right? All that matters is as long as you follow the proper steps, they're always going to match. It's always going to be exactly the same. So remember, the way we always tell whether figures are similar or not is by calculating scale factors, right? And the way you calculate scale factors all the time is by dividing. Well, we're going to go through in 2 classes from now. We're actually going to be analyzing what these scale factors, what these numbers actually mean in terms of whether something's getting bigger or something's getting smaller. Some of you can already start guessing. If it's 0.33, since it's a small number, it's going to get smaller. If it was a bigger number like before, 3 times bigger, it's getting bigger. But we're going to go into that as a separate lesson itself. I want to just go into that. But first I want to just get into showing you guys how to show that figures are similar, right? And again, always remember, biggest side with the biggest side, smallest with the smallest, and then be consistent. If you start with the smallest figure, keep starting with the smallest. If you start with the biggest, keep starting with the biggest, right? Always remember that, guys, always. And so let me show you something else before we do 2 examples with this. There is a symbol for similar, right? So let's say again, it doesn't always have to be triangles, right? Let's say we have these 2 figures. All we know about these 2 figures, they have 4 sides, right? So we call them a quadrilateral. Let's say if that's A, let's say if that's C, that's E, that's F, right? That's K, that's L, that's O, and that's R. Again, I'm not trying to prove that they're similar. I just want to show you notation when it comes to this, right? So when it comes to these figures, what we know is that to show that they're similar without always writing it out, there is a symbol. And that symbol, so let's call this one quadrilateral, right? Quadrilateral, A, C, E, F, right? And the symbol for similar, it's just this, it's just the squiggly line. Whenever you see that squiggly line, all that means is just the word similar, right? It's a quadrilateral, K-L-O-R, right? So whenever you see this, all that just means it literally just stands for the word similar. Just the squiggly line, it just represents the word similar. That these two figures are similar. And all similar means, again, all similar means is that they are both alike, right? But we're going to go more into that. What does that mean for them to be alike, right? Because there are certain relationships that do exist, right? So always remember, symbol for similar is just a squiggly line, right? And now, I do want to show you, and it's so much easier to show you this with triangles, right? Let's say we had 2 triangles again, right? And again, we're not trying to make them congruent, we're trying to make them similar, right? So, again, if this is, let's say 3, let's say 6, And let's make that 3, 6, let's make this 1, let's make this 2, and then let's make this, what, 9, 3, again, numbers don't exactly work, but I'm just making anything up right now. What you guys gotta realize is the certain relationship that exists between the sides, and again, these numbers aren't good, but I don't want to confuse you guys, let me just get rid of them, right? Let's say I actually gave you guys other ones, right? Let's say that I gave you guys, the numbers 3 and 1, right? Let's do 6 and 2. And then let us do the number, what? Sorry guys. Let's do the number 4. And then let's do the number, actually, I'm being dumb. 4, let's make this one 8, right? I'm just overthinking things, guys. I apologize for this. That's 4, that's 2, that's 3, right? We'll do that. Again, I apologize. I just wanted to make sure that this all came out exactly right for you guys to be able to analyze it, right? So, what I wanted to show you, first and foremost, let's figure out if these two are similar or not, right? The way that you always figure out if they're similar or not, calculating scale factors again, right? So we have, again, always the biggest side with the biggest side. So biggest side in this case is going to be 8. So we would do 8 divided by 4. 8 divided by 4 gives us 2. Next, smallest side with the smallest side. 4 divided by 2 gives us 2. Right? And then we have the middle side with the middle side. 6 divided by 3 equals 2. So right there, without anything else, we automatically know that these figures are similar. Right? They're similar. And the reason they're similar is because all of the scale factors are exactly the same, right? But what I wanted to go into, I wanted to show you that there is another relationship between them, right? And it has to do with the sides in terms of a name, but the angles. These are triangles, we automatically know. This triangle adds up to 180. We know that this triangle adds up to 180, right? So let's say if this angle came out to 65 degrees, right? Let's say if this angle was 85 degrees. So this one would have to end up being 20 degrees, right? The one thing we know about similar figures, regardless of the size, regardless of whether it got bigger or smaller, the angles are always going to stay exactly the same. Always. And the reason that it stays exactly the same is because of that idea that we've always talked about in geometry. Regardless of whether a triangle is small or big, automatically we always know this triangle adds up to 180, this triangle adds up to 180. So when we have similar figures, whenever we have figures that are alike, their angles are always going to be exactly the same. The sides are never exactly the same. Their scale factors are exactly the same, right? So this is one of those things I do want to write for you because it is an important fact to know. And it has to do with the corresponding sides and corresponding angles. The sides and angles that go together. So what we know is corresponding angles, right? The angles that match up together. Corresponding angles are congruent, right? Yeah, they're congruent just means that they're exactly the same. And that's always going to be true. Whenever figures are similar, and this only applies for when they're similar. Whenever figures are similar, guys, their corresponding angles are always going to be congruent. If that's 65, that's 65. That's 85, 85. That's 20, that's 20. Has to be. Whenever they're alike, their corresponding angles are always congruent. The only one that's a little bit different are the sides. Remember, the sides are not exactly the same. But what is the same are the scale factors, right? The scale factors are always going to be exactly the same. So there's a word that we use for it. So again, the sides are not the same. Nor do we expect them to be the same because one side is bigger than the other, right? But when we have corresponding sides, there's a word that we use, and that word is called proportional. And all proportional just means it changes the same way, guys. So it just means whether it's 2 times bigger or 3 times bigger, 4 times smaller, all of that. That's what proportional means. So always keep in mind, whenever we're dealing with similar figures, the angles are always going to be congruent, always. And the sides are always going to be proportional. They're always going to actually have the same scale factor, the same relationship. That's what proportional means. It changes the same. And in this case, when we did the scale factor was 2, right? And all that meant was just all the sides were changing by 2. Again, you could have done it the opposite way. You could have started with the smaller one. It's up to you, right? But just always keep that in mind. Similar means alike, corresponding angles are congruent, and corresponding sides are proportional. They change the same amount. I want to do one more, guys, just to show you and just make sure you're comfortable with calculating scale factors, right? And always keep that in the back of your mind about the sides and the angles. So I have 2 exact triangles, right? We have this one like this. And again, I do want you guys to get away from the fact of always seeing them in the same way. So this one, again, was rotated, all of that. One's bigger than the other. So we have 100, we have 75, we have 22, right? And then the other one, we have 40, we have 30, and we have 26. So always remember, don't ever go by the idea of the left side goes with the left side. Always go with the notion of the biggest side goes with the biggest, the smallest side goes with the smallest, right? So we'll start with this. We know that the 2 biggest sides are the 100. So in this triangle, the biggest side is 100. In this triangle, the biggest side is 40. So we'll put those 2 together. 100 divided by 40 is going to end up giving us 2.5. Right? So we did that side, and we did that side, right? Next 2 sides that we do. The next biggest one is the 75. The next biggest one here is the 30. So we're going to do 75 divided by 30 is going to end up giving us 2.5. Good. Now, the smallest sides, right? The smallest side here is the 22. The smallest side there is the, I'm sorry, that's a 32. I apologize, guys. That was a 32. 2 smallest sides here, the 32 and the 26. We're going to do 32 divided by 26, and that's going to end up giving us 1.23. That's going to end up giving us 1.23. So automatically, right now, we notice something. 2 of them are the same, 1 of them is different. The fact that 1 of them is different, it doesn't matter that the other 2 are the same. If all 3 aren't exactly the same, automatically we know not similar, right? It is not similar. The only way that they can be similar is if all 3 scale factors are all the same. Since they're not all the same, we automatically know not similar. If all 3 were the same, it'd be similar. So always remember that. So figure out if figures are similar, their scale factors always have to be the same. Always remember, the way you find a scale factor, you divide, right? When it comes to similar, similar just means alike. The symbol is a squiggly line, right? Whenever you just see that, it just means the word similar. And remember, angles are always going to be congruent for corresponding angles, and the corresponding sides are always going to be proportional. They're always going to change the same. Again, we're going to do more practice with this, but if you need any help, let me know. Take care.